Welcome to our channel. Modern physics has introduced us to many things that seem incredibly strange but are real, like neutron stars or black holes. And then there are mind-blowing ideas that may or may not be true, such as the multiverse. Among these, perhaps the most absurd is the concept of Boltzmann brains, a notion vaguely reminiscent of the Futurama heads, but one that cosmologists treat with a seemingly more serious name. But what exactly are Boltzmann brains? And how seriously should we take them? Let's try to understand this together. To grasp this concept, we need to start with Ludwig Boltzmann, an Austrian physicist from the late 19th century, who, among other things, helped us understand entropy and why this quantity always tends to increase in the universe. Additionally, Boltzmann explained why time seems to flow in a specific direction, from the past to the future. In summary, Boltzmann showed that many results of thermodynamics, the science that studies heat, could be understood through a microscopic description. For example, the fact that a gas tends to occupy the entire available volume is due to the higher probability of the particles spreading out evenly rather than concentrating in just one corner of the container. This is why we observe phenomena that always happen in the same temporal direction. Gases tend to spread out, but we never see a gas spontaneously concentrate in a corner of the container. Similarly, we see glasses breaking, but never the fragments of a glass reassembling into a whole glass. Although from a microscopic physics perspective there is nothing preventing these events from happening, their extreme improbability makes them practically impossible to observe. The physical quantity associated with the probability of the various configurations of a system's particles is called entropy, and the second law of thermodynamics states that in a closed system, entropy cannot decrease. Rather, it either remains constant or increases. A gas spread throughout a container has higher entropy than one concentrated in a corner, just as a broken glass has higher entropy than an intact glass. Boltzmann demonstrated that this law has a probabilistic explanation. It is infinitely more likely to observe natural phenomena occurring in the direction of increasing entropy. However, when a system reaches maximum entropy, it goes into equilibrium, and nothing interesting happens anymore. In theory, in the very distant future, our universe could reach a state of maximum entropy, with all particles distributed uniformly, a condition known as the heat death of the universe. Boltzmann's probabilistic interpretation is very effective, but it has a conceptual problem. If we observe entropy increasing today, it means that the universe must have had even lower entropy in the past. This implies that the universe, in the past, was far from equilibrium and still is today. Boltzmann himself admitted that the second law can only be explained by assuming that the universe had an improbable beginning and that it is still in an improbable state today. Boltzmann also formulated another hypothesis. If the universe had existed for an infinitely long time and had already reached thermal death, then, in infinite time, it would be possible for an entropy fluctuation to occur purely by chance. This fluctuation could bring the universe to a state of lower entropy, and from there, entropy would start to increase again. According to this idea, the universe itself could be the result of a random fluctuation from a state of maximum entropy. However, this concept has raised some criticisms. A closed system has a probability of seeing entropy decrease that is smaller the larger the required entropy fluctuation. In other words, it is already extremely unlikely that a glass would reassemble from its fragments, but it is even more unlikely that an entire ordered universe would emerge from a random fluctuation in a state of thermal death. Richard Feynman, for example, noted that if the universe were indeed the result of a random fluctuation, we should observe a small ordered region around us, while the rest of the universe should appear disordered and close to equilibrium. But that's not what we see. Taking this reasoning to the extreme, we arrive at the concept of Boltzmann brains. If fluctuations could indeed create an ordered universe, then it would be infinitely more likely for these fluctuations to create something much smaller, like a brain with illusory perceptions and memories, rather than an entire universe with galaxies, stars, and planets. This leads us to the crucial question: can we be sure that we ourselves are not Boltzmann brains, immersed in a chaotic and illusory universe? This is a question that borders on radical skepticism, similar to Descartes' hyperbolic doubt, from which it is difficult to find a way out. Perhaps the truth is that we still know too little about both the origin of the universe and consciousness itself to be able to provide definitive answers. What is certain is that, to advance our understanding, it's not enough to get lost in abstract reasoning, no matter how fascinating, but rather, we must rely as much as possible on direct experience. Thanks for watching. Leave a like and subscribe to the channel to support us.